Okay, so I'm just going to pick up from the last video I've made, and in the last video what I've done here is we were given this matrix here, and it's a 3 by 3 matrix, okay, and what we're asked to do is calculate the characteristic polynomial of this 3 by 3 matrix. And because there are just as a remark, because there are three dimension, and it's a square matrix 3 by 3, that means that we should get a polynomial of degree 3, as in the highest power should be cubed. So that I'll just go right down to the end here, so we'll see how far we got. So this is the characteristic polynomial we got: lambda cubed minus 5 lambda squared plus 8 lambda minus 4. Okay. Now, just as a remark, it turned out to be quite easy to solve this. Working through it to actually you sort of, well, not easy, but like a sort of clue became evident. Now, what I'm going to do is work on the basis that there was no sort of obvious clue. Okay. Now, first off, just going to remark this is a polynomial of degree 3, so we expect 3 roots to this. Okay. So 3 roots. Okay. So that's to say 3 possible values for lambda that solve that equation, that are consistent with that equation. Okay, and what I'm going to call them is A, B, and C, just for the time being. Okay, so if A, B, and C are the roots for an equation, that means lambda equals A, lambda equals B, lambda equals C. Okay, now we might rewrite what I've just written there, this as follows. Okay. Lambda minus 1 equals 0, or lambda minus A equals 0, lambda minus B is equal to 0, and lambda minus C is equal to 0. Okay. Now, if we have, essentially if we're writing this as a polynomial, which that is, those A, B, C are the roots for, what we would do is write it like this: lambda minus A is equal to 0, lambda minus B is equal to 0, lambda minus C is equal to 0. Oh, sorry, lambda minus A times lambda minus B times lambda minus C, that is equal to 0. Okay, now that's a sort of important juncture. Okay, this part here. Essentially, this is the form that a characteristic polynomial will take for a 3 by 3 case. If in a 4 by 4 case, there will be 4 of them. Okay, now what I'm going to just sort of remark upon here is I'm going to bit by bit calculate this out. So leave lambda minus A alone for the minute, and what we have here is lambda squared minus B lambda minus C lambda plus BC. Okay, and when I calculate that out a little bit more, what I would get is as follows: lambda cubed minus B minus C. I'm going to put the plus there and put that in brackets. Lambda squared minus or plus BC times lambda, and likewise minus 8 times lambda squared. Well, it's actually plus, but I'm going to plus minus, but I'm going to actually just reverse the order there. Sorry, just a little bit of digression there, just make it easier to add it later on. Minus A, B, minus A times plus there we go. Minus A times C lambda, and so on. But the last bit is the most important. Essentially, I'm just multiplying it out. But the last bit is A, B, C. Essentially, what I'm going to say getting at here is as follows: that this would be equal to lambda cubed, and then you have all the other terms in the middle, which I'm not really particularly interested in, minus A, B, C. Okay? So the first term is lambda squared. Okay, that's fine. Or lambda cubed. But the last term is what I'm specifically interested in, ABC. Minus ABC. Okay? So, minus ABC. So essentially, what I'm going to do now is try solve this here. This get the roots for this. But what I'm going to sort of remark upon first off is minus 4, which I just had up there, is equal to minus a, b, and c. Or minus a times b times c. Just as a remark, so 4 is equal to a times b times c. Now, just as a remark, what I'm going to do there is remark that in the case of undergraduate tests where you've got about 15 minutes to get the eigenvalues, they're usually going to be integers, or close enough to integers. You might get a square root or something like that. I don't know, but usually they're going to be integers, plus or minus integers, okay? So what we could do here is guess answers, okay? Now, the reason I'm going to sort of pick out a few and sort of suggest that they might be the answer yes or no. Well, first off, in this case, 0 is definitely not going to be an eigenvalue. Okay, because if we had a times b times c, that means this other side would be 0. So 0 is out. Okay. How about plus or minus 1? That's a potential case. Plus 1, minus 1, maybe. Likewise, plus or minus 2, maybe. Plus or minus 3. Maybe not. Probably not, but maybe. So essentially you're going to say no. Not likely. Okay. Now the reason is 3 does not divide into 4. Okay. So what I'm going to do here in this particular case is try out a few of these. I'm going to try out this one here. And what I'm going to do here, lambda cubed minus 5 lambda squared plus 8 lambda minus 4. We're going to try out a few trial solutions. So lambda cubed minus 5 lambda squared plus 8 lambda minus 4 is equal to 0. Okay. Let lambda equal to 1. What will we get? 1 cubed minus 5 times 1 squared plus 8 times 1 minus 4 is equal to 0. That is 1 minus 5 plus 8 minus 4 is equal to 0. Yeah, that works out. So we've actually found one of our values. We'll call that one a. So a is going to be 1. Okay. So let's try out another one. What I'm going to do here is, you might be able to sort of deduce a bit further. Let's try out let lambda equal to minus 1 and see if this works. Okay, so minus 1 cubed minus 5 times minus 1 squared plus 8 times minus 1 minus 4. So this is minus 1. So what we have there is minus 5 times plus 1. So that's minus 5. Minus 8 minus 4 not equal to 0. So this lambda equals minus 1, no. Okay, so we'll move on to lambda equals plus 2. Okay, so 2 squared, or 2 cubed, minus 5 times 2 squared, plus 8 times 2, minus 4. So what we have there, 8 cubed is 8, or sorry, 2 cubed is 8, minus 5 times 4, that's 20, plus 16, minus 4, that is equal to 8 minus 20 plus 16 minus 4, that's equal to 0. Okay, so we found the second one here, b is equal to 2. So if, remember, a times b times c is equal to 4, 1 times 2 times c is equal to 4, that means the last one is 2. So the eigenvalues that we are looking for, the solutions to the characteristic equation, as I'm going to write this out fully, the solutions to characteristic equation or characteristic polynomial are as follows. 1, lambda equals 1, 2, and 2. Okay. Just as a remark, I tend to write them in ascending order. Not that it really matters, but it does sort of help to keep a consistent order when you're doing these sort of things. So correctly, that's a sort of a vector, but I'm just the point of what I'm doing right now is solutions to the characteristic polynomial. 1, 2, and 2.